our main speaker, our first speaker tonight is Jennifer Hartwig. And Jennifer is a member, active member of ORION. She's been our vice president, a program chairman, she's shown us how to give excellent presentations. It's just, I kind of marvel at that because she has it together and it all comes off really well. And they make me think. So I've been looking forward to this. Jennifer is an exercise physiologist. Her heart is in astronomy. And as I told you all ago, she's rumored to have a great enjoyment of the writings of actions of Tesla and Oppenheimer. So she's currently employed over at UT doing advising at the graduate student level, which is pretty difficult because by that time we're very special people and it's hard to advise. But you're doing undergraduate advising too, aren't you?
I don't do graduate, I do undergraduate.
You just, okay. I was thinking of some of your stories and I said, these surely must be undergraduates that the stories come about.
They're finding their way.
Yeah, it's really good. So she's been at University of Tennessee and at Carson Newman, and participates pretty strongly in ORION and Knoxville observers and comes up to Tamke Island Observatory and always contributes. So she's a nice example of contributing. And she was inspired because this is the month of women in science. I hope I've got that right.
Just have to wait and find out.
Wait till the end of the month?
Huh?
Oh, you're going to tell us.
I'm going to tell you.
This is great. Okay, Jennifer. A great title. Glad to have you here.
Thank you. Now that he's set me up for failure, talking about the presentations, I actually don't like to read the presentation, but tonight I might have to because I started reading about this several months ago because I thought I was going to be looking at about a 5-year time period, which turned into roughly a 40 or 45-year time period. And I got kind of drawn in by the people in the story and made it a little hard to focus. I think we'll all be better off if I use my notes more so than not. To give a little background, I just got back from a meeting in my true profession with the American College of Sports Medicine, and one of the best presentations that I heard was from John and I's former professor and friend, David Bassett, who is a well-renowned researcher in his area. But the presentation that he did that resonated with me the most had to do with the background and the history of one of the researchers that we had read about for years. And I enjoyed seeing the researcher not from the research side, but from the person. And so because I'm in astronomy and my background is exercise physiology, I have to look at this as almost an outsider and not a technical person, and especially with some of the people in this room here tonight. So when I pick these subjects, it's because I want to know it. I want to know this topic from the other side, from the non-technical side. So keep that in mind as we go through today. So I picked this title, and hopefully you'll learn why in a minute. I do want to get the background of I am not a feminist, period. I happen to believe that women are very equal. I think we were made just as equal. I've never had reason to think anything different. But I wanted to just present maybe the history of women in science in a little bit different manner. We hear a lot about women in science maybe having been held back, obstacles put in their way. I spoke a couple of years ago about 3 women who really went through some difficult times, one to the point that she was murdered, and so I thought that was pretty extreme. But I also think that there's more often than not a story of men that were close to these women that succeeded, that were actually very helpful. And I don't think we hear enough about that kind of relationship in science, or at least I tended not to hear about it. So that's a little bit of the background of what I'm doing. So December 15th in December of 2015, I'm sorry, the United Nations General Assembly designated February 11th as the International Day of Women and Girls in Science. So this is the third, this past February 11th was the third anniversary. It's only the third time it's been celebrated. And the goal was to recognize the fact that women are less represented in the scientific world, maybe figure out what are the reasonings behind that. And I'm not going to go into that as much today, but I have to say that as a woman, when I see a day designated for women in science, part of me is thinking, do we really need this? Women have been doing science for years, and they've been doing it very well, and they've been doing it successfully. But then I have to stop and think that not all women come from the same perspective that I do. I grew up, my dad was a mechanical engineer. He taught me growing up and explained things often ad nauseum, and to which I would listen, and I enjoyed that aspect of it. He never treated me like I was a girl I wouldn't be interested. He always just assumed I wanted to hear what he had to say. My mother went back and got her master's degree when I graduated from college. Her background is in education, so between the two of them, my dad was an explainer, and my mother constantly said he didn't do it well enough, that he needed to learn how to teach better. And so I listened to them go back and forth, and out of that, I kind of got a very strong sense of being able to ask questions and being able to say, I don't know, and being able to try and learn things and figure it out. So for me, the idea that women couldn't be strong in science was completely foreign. But I do recognize that there are women who haven't had that same support. There are women that grow up in parts of the country or the world where maybe they are not given those same opportunities. So from that aspect, I guess I'm kind of comfortable with having to have a day to recognize for women and girls in science. March is actually Women's History Month, so the women in science get one day, and I hope one day that we won't need to recognize that publicly. So I started to think about when I joined this club 5 or 6 years ago. I walked into the KO meeting, and Roger was there as friendly as he ever was. He didn't know who I was. I had really no reason for being there other than interest, but I was welcomed with open arms. The same thing with Orion. When I walked into there, I can remember the first meeting, walking down and talking with David, and he was very accepting. So I started to think about, you know, what is it that our club can do if we want to influence girls and really anybody into the world of science. So I came up with just a couple of things, and I think it's important to inspire people and to learn about role models. Not just the science, the role models, because sometimes the story of the people doing the science is almost as interesting. So maybe have some stories to throw out the people that can relate to. And then this is what I think we do well. Share what you know everywhere with anybody who will listen. And I think we do this really, really well. I just wish we had more opportunities to do that more often. So if we get back to this date, I think if we can find a way to share what we do, I think it's important to be able to encourage women in science. So this is a story that I wanted to talk about, and they're called the Harvard Computers, and I kind of thought, I almost titled this hashtag #MeToo in parentheses not. But I decided that that would be politically not good, and maybe it would cause other problems. And then maybe I thought Hidden Figures, the first version. So if you've seen the movie Hidden Figures with the women and the rockets, this is kind of the Hidden Figures with the women and stellar classification, maybe just a lot earlier on the time spectrum. In the middle, you can see the man that I wanted to bring out a little bit in regards to the relationship with these women and how he helped them through their scientific endeavors. The interesting thing is, though, that these group of women were actually referred to, and this man, by the way, his name is Edward Pickering. You may know his brother, William Pickering, who is also very prominent in the world of astronomy. But Edward Pickering, this group of women, they were eventually called the Pickering Harem. And that's not a flattering term. So if you've ever heard that term before, and you think, gosh, he really wasn't very good to these women, how horrible of him, I want you to kind of hold back and think about, after we've talked a little bit about what he actually did, and the fact that I think that his relationship with them was anything but authoritarian. I don't think he was sexist. I think he was extremely helpful to these women, and I guess society just needed to put a label on it because at that time he was still more quote-unquote powerful in the world, but he was starting to open the doors for a lot of people. I find it interesting that this is about the Harvard computers. This story, I'll give you some dates, takes place during roughly the 1880s, and to put that into time perspective, the year 1886 was the year that Geronimo surrendered. So amongst the wild, wild west, we have women getting involved heavily into science yet again, and not the first time. But at Harvard, just prior to this story taking place, there was a physician and a doctor by the name of Edward Clark, and he wrote a book called, in 1873, called Sex and Education. And here's a quote from him, from that book, just 7 years before this story takes place. This physician wrote that a woman's body could only handle a limited number of developmental tasks at one time. That girls who spend too much energy developing their minds during puberty would end up with underdeveloped or diseased reproductive systems. We find this entertaining, don't we? But at the time, it was considered to be tried and true. Thankfully, Harvard employed more intelligent people like Pickering. He looks like somebody I know, and I just haven't been able to place who that might be. Pickering was an 1865, think of the years here, 1865 graduate of Harvard. And he graduated at the age of 19, Dave, you'll appreciate this, with his degree in physics. And he taught physics at MIT until he turned 30 when Harvard asked him to come be the director of their observatory. Pickering was known for being very hands-on. He was recognized as one of the first people to develop a lab manual, to do experiments. He encouraged his students to do experiments. And at the time, he invited women to come to his lectures and listen, women who wanted to learn about astronomy but were otherwise prohibited from doing so. So he was very hands-on kind of sciencey. So when the opportunity came up to be the director of the Harvard Observatory, he jumped at that job opportunity. Now there was a more famous astronomer in the United States at that time. His name was Simon Newcomb, and we're going to hear a little bit more about him later. He declined the position that was offered to him at Harvard, citing that the observatory lacked several things. And for any of you who've wanted to go work somewhere, you can identify. Number one, they lacked funding. Number two, they lacked equipment. And number three, they lacked skilled workers. So he turns the job at Harvard down, and Pickering says, no problem, I got this. And so from his new job, he became pretty adept at securing some funds for the observatory. And the irony of this all is that one of the first people to give funding to his observatory was a woman. One of the first person to donate equipment to his observatory was a woman. And the shortage of workers that he eventually found ended up being 80 women. So they have a kind of this very good relationship of him relying on women from the very get-go. This is a picture of the Harvard Observatory. I think it's, I meant to look to see what the status of this building is now. They still house the glass plates that they took there. There was a recent flood not too long ago, and it destroyed, I think, about 60,000 of them. There's over 500,000 plates that were taken, and George, you can appreciate this as an astrophotographer. This is in the very early days of being able to take a picture, period. So this is the building of where this story took place. And there's going to be 5 women that I'm going to focus on. The first one is named Anna Draper, the second one Catherine Bruce Wolfe, the third one is Williamina Fleming, the fourth is HENRIETTA LEAVITT, and then Annie Jump Cannon, or Annie Cannon as I'll call her. I'm going to briefly mention another one by the name of Antonia Mori, but what these accomplished as a team under the direction of Pickering, and actually not even under the direction, I guess he did kind of direct it, but he also welcomed their ideas, and we'll see some other things that he did to help them along the way. So these are the women we're going to talk about. The first one I'm going to look at is Anna Draper. Anna Draper is there on the right. I cannot imagine having that hair in 1880. I mean, how do you just mess with it. But this is this very lovely woman. And her husband on the right, those you've probably heard of him, his name is Henry Draper. How many have heard of Henry Draper? Oh, yeah. Dave, okay. So you've heard this, and you'll figure out from where in a minute. But Henry was actually a physician, and he had a love for astronomy to the point that let me read a little bit about what his father was. And before I get there, I wanted to point out that the date is kind of ironic because 132 years ago yesterday, the Harvard Observatory received a $1,000 check, which Google tells me today is the equivalent of $15,000. I don't know if that's true or not. And it came from Anna Draper. And you might ask why Anna Draper would donate that kind of money. And it would be the first installment that she would make, along with many others of that. So you got to ask, this is a woman whose, I think her hobby was, she was an artifacts collector. And so why would she donate the money? Well, she donated it because she had what I like to call radically different relationship with her husband of 15 years. She was not an astronomer. He was the doctor. He got into the hobby of astronomy, but she came with him to spend the time with him. She wanted to be together. And she became so close to him with the work that she became his most skilled technician. And he died at the age of 45 from complications of pericarditis. And this woman, who had no background in really anything scientific, said, I'm going to carry on what he wanted to do. So the question might be, what did Henry Draper want to do? So what was Henry Draper's goal? Manoni and McAllister, you can't answer this. Or you either. Not you, her behind you, Jacqueline. Anybody know? Henry Draper wanted to classify all the stars. Everything else had a classification. Birds, trees, insects, you name it. This guy wanted to classify the stars. And he had a little bit of experience with some photography. His father was the first person to, it's called, I think you pronounce it daguerreotyping. Is that how you say it? Henry Draper's father, the guy on the right, was one of the first people to provide a daguerreograph of the full moon. And this is what that looked like. George, you can appreciate the clarity, can't you? But you got to think back, this is the 1800s. Henry Draper's father, John was his name, was also the one who photographed Vega as a star. And so Henry Draper grew up with kind of an affinity to photography. His dad was a chemist. His dad was particularly interested in the chemistry of light. And so Henry Draper grew up with this, and he thought, I'm going to catalog all the stars in the sky. So he and his wife set out to take pictures of the sky. And if you think back to the times of Galileo and early observers, how do we have records of the stars and what they look like? Well, we have them through their hand drawings. And if you've done any of the stellar observing list, what did they tell you to do? Draw out what you see. And that was the way that it was done for many, many years. But photography was now better at perceiving some things than the human eye, so they started to take pictures. And then Henry Draper decided that he was going to take it a little bit further, and like when Newton split the light, and I guess it was von Fraunhofer, is that who it was? When he looked at the light in the spectrum a little bit, he saw the lines. And so Henry Draper said, I'm going to take this a little bit further. I'm not going to photograph just the stars. I'm also going to photograph the spectra. So if you look at the plates, it's the stars plus their spectra after it had been split through a prism. And he wanted to find out what was in common and categorize those like that. I think it was the father. Does anybody know what this is? Picture of? This is something we look at all the time. It is the trapezium within the Orion Nebula. This picture was taken by Henry Draper, and he was the first person to photograph the Orion Nebula on September 30th of 1880. And this is, I think, as far as I can get, the copy of what he had. So you can see photography had a long way to go still. But what he did is he put the prisms to split them into a spectra, and these are some pictures from the Harvard Observatory's records of kind of some of the different spectra that they might have been looking at, only it didn't look this pretty on the photographic plates that they were doing. The continuous spectrum, obviously if we look at it, looks like this. They had some of the absorption lines in the spectrum, and so they started realizing that some stars, while they didn't understand why, had the same markings, and so they wanted to classify those all together. So you can see how pretty that looks, and that wouldn't be too hard to classify, except for the fact that this is what one of their plates look like. Can you imagine looking at that? This is one plate. They are about 8 by 10 in size, and there's 500,000 of them that were taken over the course of these 20 or 30 years. And so what the markings are markers of location. They wanted to orient them in the sky, and all of the stars on all of these spectra were categorized in that way. So Anna Draper, once she decides to give that money to the observatory, she said, I want to carry on what my husband has started. So here we have this woman who doesn't really have any background at all. And within her husband's death, within just several years, she approaches William Pickering. Because of Pickering's love for physics, she knows that this guy wants to catalog the sky. And she approaches Edward Pickering and gives him the money. And within 6 months of negotiating, carrying out a Henry Draper Memorial Catalog, which will catalog all the stars, she has given him money, she has provided him with a telescope, and she gets the project going. Now, doing that in today's time would probably take a year and a half worth of meetings, if nothing more than that. But she got the ball rolling. She was an outsider, she was a non-scientist, but she was not rejected as part of a scientific community by William Pickering. He took her in. Now, obviously, he had reason for doing so. He needed the money, he needed the equipment, but he honored her, and he continued to work with her throughout the time period that she was working with him. We're not sure if this is a picture of Pickering. I've seen some people say yes it is, no it's not. But after Henry Draper died, Anna, his wife, dedicated this telescope to the observatory at Harvard. The second person that I want to talk about is Catherine Bruce. This woman also was not an astronomer. She was not a scientist. She was a philanthropist. Her father, I think, had something to do with typesetting. She had inherited a lot of money from her cousin, I believe. And what she wanted to do was, this is a picture of her when she was very, very young. And I love this picture for some reason, because she's obviously thinking something. But she didn't start thinking about astronomy till she was in her 80s. So this is obviously a picture of her not in her 80s. If this is 80, this is how I want to look when I'm 80. And so she developed this love for astronomy, and what prompted it was she read in a newspaper article by the same Simon Newcomb who turned down being the director of the Harvard Observatory. He was the renowned astronomer in the United States at that time, and he wrote an article in a magazine in the year 1888. And his opinion in this article was that there would be no other significant astronomical discoveries during the present time or in the future. So let's think on that a little bit. To which this woman, now in her 7th or 8th decade, scratches her head and said, "Are you crazy? Of course there's going to be." And so what she decided to do was something that I can totally relate to. Once you get hit by the bug of astronomy, you go get a book. And she got a book by Charles Young called The Elements of Astronomy. And this quote is hers. She read that book, and it was almost like she lost herself in it. And she said, "Well, there is in every lowest depth a lower deep, and I fell far into it." And what she's saying is that as she learned more and more about astronomy, she absolutely fell in love with it. And I think a lot of people in this room can relate to that. So what Catherine Bruce decides to do to this Simon Newcomb is to say, I think you're wrong. I think you're very, very wrong. And she had some money, and she, about this time, had read an article for Pickering, who was looking for donations to this Harvard Observatory to get some equipment. So Catherine writes him a check for $50,000. Over the course of 11 years, she gave him $275,000 during the last years of her life. And not only to Harvard, there were some other well-renowned universities that she gave it to, but predominantly to him. And the lenses were crafted in France. I think it took a couple of years, of which she actually made a visit over there to say, guys, what's taken so long? And she got that done. It brought this Bruce telescope back to Harvard for a little bit, but then they moved it to Peru because some of the Harvard glass plates were taken in the northern hemisphere as well as in Europe and as well in Peru. And the Bruce telescope ended up there. She also wanted to continue proving Simon wrong, that we haven't reached the limits. So she bought the telescope. She donated funds to Edward Pickering. She also established later in her life the Bruce Medal, if you've ever heard of that. It's been awarded to scientists all over the place. To Pickering was one, Hubble was one, Rubin was one, Spitzer was one. So there's some very famous names that this medal has been awarded to over the years. Does anybody want to guess who the first one was that got it in 1898? 1898? Nope. It was Simon Newcomb, the guy that said, we have not discovered anything else. So this unscientific woman prods him a little bit to say, wake up. He finally decides, okay, I guess I better. And he does a little bit more work and finally says, okay, maybe there's some things to discover. So I think it's karma, actually, for him to say that and for this woman to kind of prove him wrong. So we have two women here who have helped Edward Pickering with the initial problems that he had at the Harvard Observatory. Neither of them were scientific in training, and I think that's important because people bring all sorts of things to the table to promote science. And these two women represent that form, and we don't hear really that much about them. By the time they got these telescopes, Harvard had the largest observatory outside of the US military. So they had a pretty well-connected system going, and they were all taking these photographic plates that William Draper had started. They were taking so many plates now that they were coming in so fast that now Edward Pickering had another problem, and that problem was finding people to analyze them. So he did what any smart man would do. This is a picture of that Bruce telescope, by the way, that was donated. It was moved to Peru, and I actually today just found something that said the current curator at Harvard found the lenses for this in a box. They had been sent to, they were in Peru and then later sent to Africa, I think, and they were still in the box, covered up with pillow and blankets that mice had now made their homes in, but she rescued the lenses and they're now on display. So when all these plates start coming in and Edward Pickering says, I need more people to look at these, we can't do this fast enough, we're categorizing now the southern hemisphere and also the northern hemisphere. So he does what any good man does, and he hires his maid, because that makes perfect sense, right? Williamina Fleming is who we're going to talk about next, and she literally was his maid. And if you think back to the Harvard computers, I know this is a shocker, but computers at this time were not electronic, they were people. And they did all the calculations over and over by hand. They were looking at this spectra, they were trying to make all these notations, making calculations by hand. Williamina Fleming was his maid. She, actually at that time, the Pickerings lived at the observatory, and he saw how diligently she worked, and he hired her to do work. And he got so frustrated with the men that were doing the calculations, and this is tradition, I couldn't find anything to actually support this 100%, but I like the story, it's great. The men were not doing well with the calculations, and so Edward Pickering looked at him and said, my Scottish maid can do better than you. And he proceeded to hire his Scottish maid, Williamina Fleming. He hired her largely because she thought she was a good worker, but there was another reason that he hired her. Remember I said he had three problems. He had lack of funding, lack of equipment, and lack of workers. So we have some funding, we have some equipment, and we have no workers. And we still have limited funding. So what do you do when you have limited funding but need more workers? You hire them cheaply. And women at the time could be hired at half the rate that the men were making. And the argument for doing this was that the men needed more money to raise the family. But Williamina Fleming posed a little bit of a problem for that because she was married, she was pregnant, and her husband left her. And so now she has faced with having to raise a child on her own, but still working for half the amount. So there never was any more logic presented about why they worked for half that amount of money. So Wilhelmina Fleming has the child. She actually names him, if I can find it, after Edward Pickering. The name of the child altogether I have lost here. But she named it after him, but put Fleming at the end of it. I think it's Edward Charles Pickering Fleming, I think is the name. So there was all sorts of good stories floating around on how that one might have happened, but there's nothing to suggest that it was true. So she comes back and leaves the baby in Europe with her family, and she comes back to the United States to the Harvard Observatory because this is what she wants to do. She was actually a teacher at the age of 14. She just couldn't find anybody to employ her in anything meaningful. Pickering taught her to do the calculations, and she did them so well that he asked her to teach other people how to do the calculations. So Pickering has solved the problem of finding workers because now he's able to hire women. Wilhelmina Fleming was one of the people that he put in charge of hiring the women to work at the observatory, and it's said that she turned people away. They had so many applications for people wanting to work there, for women wanting to work there, that she had to turn them away. Once the women got there, they did not want to leave. So this does not gel well with me if you're going to say that Edward Pickering was somehow, the Pickering harem just doesn't hold true. Apparently he respected them, he taught them, he supported them, he put women in charge of doing things. Wilhelmina Fleming is responsible for the first publication of the Henry Draper catalog. She herself is largely believed to have categorized 10,000 stars, looking on those little plates by hand, and she put that together with the support of the other women that were also working there at the time. She developed a system to look at the stars and classify them, because remember, we wanted to do more than just document where they were. They wanted to know, how do we classify these stars? So Fleming set up a system and labeled them A stars through P. Just use the letters A through P. And what they were doing was looking at the spectral lines for hydrogen. And so she devised a system to organize them by the strength of the hydrogen lines. And she started with the letter A, and she went up through the letter P. And that's how the first Draper catalog was categorized by that. She did such good work that she was the first American woman that was given honorary membership to the Royal Astronomical Society, which up to that date, they didn't start allowing women in until 1916. This was in the early 1900s. Only 5 other women, or 5 altogether, have gotten that recognition. She's one of them, Caroline Herschel is one, Mary Somerville is one, and there's 2 others that are escaping my mind right now. But she was in a fairly small group, again, an untrained, non-scientific woman who just had a love for what she was doing. She died at the age of 54, and she had the word the word astronomer put on her tombstone. So kudos to that. So Wilhelmina Fleming, these are some of the spectral lines that she might have been looking at. Nothing they looked at was this pretty. It was all much more smudged in nature, but this was kind of a beginning to her classification system. She was also the first one to document the Horsehead Nebula. She was the one that found it and noticed it. She had, with her, she discovered 10 nova, 310 variable stars, as well as the Horsehead Nebula. So she did a lot of work in her time for a woman who was a maid, and proof that we can all move up if we want. The next one that I'm going to talk about is Henrietta LEAVITT, I've heard it said both ways. This is a picture for her. She was born, it always strikes me the day that people are born, or the year. She was born on July 4th, 1868. That is roughly 100 years before I was born, and it astounds me to think of what women at that time and men at that time and anybody at that time was thinking as they sat and came up with a lot of this original work. She died at the age of 53 from cancer, but during that short lifetime she did an awful lot of work for the world of astronomy. She was an educated woman with a college degree, but it wasn't in astronomy. She took a course in astronomy in her latter part of her senior year and fell in love with it. She took another course after she graduated, and from there on, she actually sought out the Harvard Observatory to work there. She was nearly deaf. She had an illness and she couldn't hear. She would often later claim that this is what made her focus so well on her work, was that she lacked the hearing, so her vision kind of took over. She had heard word that the Harvard Observatory was a fantastic place for women to work. She decided that she wanted to go there and work, and she was allowed to do that and invited by Pickering. Pickering's primary goal, if you recall, at Harvard was to categorize stars by their types, including the magnitude, the location, and their spectra. So he put her in charge of the plates that were taken from the Bruce telescope that was now in Peru. That Bruce telescope, I think, was a 23-inch refractor, if I'm not mistaken. It was churning out plates left and right, and so from the southern hemisphere, she was looking at these cloudy, nebulous areas, which we now know to be the Magellanic Clouds. Back at the time, I don't think they realized that they were outside of our own galaxy, but that's what she was looking at. And so one of the first things that Pickering wanted to do is he said, okay, we've all agreed on how to look at stars and classify their magnitude by looking at them on paper, but what about on photographic plates? How do we make a consistent, if we're going to kind of transition to classification, we've got to somehow make a smooth transition, and Henrietta did that. So she developed a system to standardize the brightness of photographed stars as compared to the ones that were drawn. She looked at 299 of those 8x10 plates in order to do that from 13 different telescopes all around the world. She used logarithmic equations to place the stars in order by magnitude, and this was later accepted by the International Committee on Photographic Magnitudes in the year 1913. That was not her, her best-known contribution. When she looked at these large and small Magellanic Clouds down from the southern hemisphere, she was tasked by Pickering to look especially for variable stars. Over the course of her career, she would discover 2,400 of them visually. 1,777 of them were from the Magellanic Clouds. And so the kinds that she was looking at was the CEPHEID variables, which we now refer to as the candlesticks of the universe. And at this time, there was no way to really adequately judge distance. What Henrietta LEAVITT did after studying these over and over, and she would stack plates one on top of each other. They were taking pictures of the same area of the sky at the same time on a repetitive basis, so they could just stack the pictures one on top of each other. And what she noticed was that they would start out dim, they'd grow bright very quick, and then they'd dim down slowly. And these stars, these variable stars she was looking at, all had that same pattern: a very rapid brightening, a slow dimming, a very rapid brightening, and a slow dimming. And what she did by observation was realize that the frequency by which they varied was related to how bright they were. And so she was able to start classifying stars by the frequency of their, the dimming, the brightening and the dimming, and she was able to say, okay, these stars are all in the same cloud, right? So if I'm up here, this is my cloud. If I'm up here and I have 2 flashlights in my hand, and you all are looking at them, they're roughly the same distance from you, right? Okay, so if one of them appears brighter than the other, it's not because it's closer to you, right? Because we're at the same distance. What she noticed was that these stars that were roughly the same distance from her as an observer were differing in their brightness. So she determined that that was due to their absolute luminosity, and she developed a system for being able to track that. This was the actual plate, I think, at least as I heard it. Those are all the markings. That's the Magellanic Cloud, and this was actually the plate where she started to use some of the relationships of the brightness of these stars to be able to determine the luminosity versus their period of when they became bright and then dim. And she correlated all of that. This was what she was noticing. The CEPHEID variables have a fairly distinct pattern of growing in magnitude very quickly, and then of diminishing a little more slowly, and then repeating that. So across the bottom is the time that it took for them to go from minimum to maximum and back. And then the y-axis is their magnitude that they were looking at. And so she started to make this comparison, and she published this, I believe, in 1906, her findings of the patterns, and she published it in a book, which was the Harvard Circulars, where she put it. So this is some of her graphs that she drew, and you could see her making kind of the relationships. The right is the logarithmic relationship of those, and she established what we call now the period luminosity curve. And about a year after she published this information, we have a guy named Hertzsprung. His first name I'm not going to butcher, so I'm just going to call him Hertzsprung. This was her writing, but Hertzsprung read about this relationship that she had discovered. He was looking at some clusters of stars, and because they were in the same gaseous cloud, he again assumed that they would be at a relatively similar distance, and he noticed the same patterns there. So he picked one of the clouds and he plotted them on this diagram. Outside of Dave and that Dave and you, does anybody know what we call this today? Yeah, the Hertzsprung-Russell. It kind of gives you away. I shouldn't have said his name. But this is the Hertzsprung-Russell diagram.
Main sequence stars with that.
Huh?
And their main sequence stars.
Right. And so the Hertzsprung-Russell chart in and of itself could be an entire lecture with the information that you can get. But if you recall, the phrase that I put up with the beginning, it said she would have made a first-rate housewife, but she took up cleaning among the stars instead, or something to that effect. This is essentially the result of the women cleaning up the sky, because what they did was they classified everything so that we could kind of organize it. HENRIETTA LEAVITT made an observation using those little tiny plates, and she looked at them endlessly for hours and hours and days upon days. And eventually we come up with this, which is how we have a good understanding now of how stars are born and how stars die, and whether they're going to explode or whether they're going to become a white dwarf. So what her work told us an awful lot about how all of this happened. So I think, you know, when you see the Hertzsprung-Russell chart, which actually looks more like this today, this is the pretty version of it, which I think is really kind of cute. But what LEAVITT did was give a good basis as to how we could start to make some of these interpretations about the stars in the sky. I'm going to talk about the last woman here in a minute, and she kind of contributed this a little bit. Let's see. What they were able to use from this is what I wanted to get to. The period luminosity observations that LEAVITT made using these very bright CEPHEID variables has allowed astronomers to calculate the distance of objects, and that I will let Dave McAllister tell you all about how that's done and the math involved with that afterwards if you want to ask him. But up to a distance of 50 to 75 million light years is what I found. It was a pretty big distance. And so what this allowed us to do is, or not us, a very famous man, Edwin Hubble, used this to realize that that Andromeda galaxy over there is not a cloud, it's actually outside of our own galaxy. It's something different. And they were able to start doing this by the measurements and the relationship that this woman determined. Harlow Shapley, who would follow Edward Pickering, as the second observatory director, used it to determine that our sun, shockingly, is not the center of our own galaxy, that we're just kind of floating around on the Orion arm out there somewhere. But LEAVITT's pattern recognition is the one that made all of that worthwhile. And I hope that some of the more educated people in the room in the world of astronomy realize this. I didn't until I read about this. In November 2008, the American Astronomical Society agreed to recognize the period luminosity relationship as Leavitt's law. And I had not heard it officially done that. Now, officially, the American Astronomical Society, I don't think, can label anything. It's called whatever it's called, and I don't know that they can force a change. But I guess as educated people in this room in astronomy, instead of calling it the period luminosity relationship that we now refer to it as the name that it rightfully deserves for the work that she did. Her coworkers would often cite her as having one of the most gifted minds at Harvard University. There was a lot of back and forth about, had she been allowed to use her mind instead of doing these very rote tasks, what else might she have come up with? But I think what I like about this woman is that probably what she was doing was below her academic level. She probably was much more gifted to do something else, but she was very happy doing what she did and being the best person at it. And to me, that's kind of motivating to say sometimes we don't get to do what we want, but whatever you do, be the best at it and do it well. And she's evidence for that. So the last one that we'll talk about is Annie Jump Cannon. This woman followed up LEAVITT, and she's really well known for now being kind of the mastermind of the current stellar classification list that we get. This woman, of all the ones that we have talked about tonight, really was educated in the world of astronomy. She got a degree in physics from Wellesley College. She would eventually end up with a master's degree from there. She was inspired by her mother, who took her out to view the constellations at a very young age. She had pretty much a desire of what she wanted to do. Like LEAVITT, she was nearly deaf, and so there's a lot of argument as to whether or not that played into her very good visual skills. She was unable to find a job, whether or not because of her deafness or not, they don't know, but she took up the habit of two things that would help her out. Number one, she learned spectroscopy while she was in school. And the second thing that she learned was to take photography. When she couldn't find a job, she went and became a photographer. She chased some eclipses around the world. And so those two things combined together, when she goes to Pickering and says, "Do you need help?" He's like, "Yeah, you know spectroscopy and you know photography. Of course we have a place for you here." So what she did was to revisit that system that Wilhelmina Fleming had developed for classifying the stars, the ones that she lettered A through P. And she came up with another system. There was another woman in here, Antonia Maury, and she's an interesting cat in and of herself. She was the niece of Henry Draper. Maury had refined Fleming's original classification just a little bit, and then Cannon took it a little bit further, and she simplified it a little bit. And so she made it down to the classifications that we see here. And so instead of A through P, we have O and then M. And the way to remember that is, "Oh, be a fine guy, kiss me."
Yeah, but he didn't want me to.
Well, I just happened to be looking at you, so. But that's how we remember this. And so what they did, in between the time Fleming came up with her A through P, because the question is always like, well, how did O and B get before A? It's completely out of order. It makes no sense. But when Fleming had first organized A through P, they just knew that those stars had the same signatures, but they didn't really understand why. And so in between that time, they had learned that the very, very high temperatures of the O and the Bs were eliminated the hydrogen spectra from those stars, and so it moved O and B in front, and the rest of them are in order. Cannon did away with some of the other lettering. She inserted the 0 through 9 classification, and which is what we use today. So for example, our star is a G2, I believe. G8?
Yellow dwarf G8.
Okay, I thought it was a G2. See, I learned something. But it is a G, so I get 50% credit for that. But they simplified that a lot, and so this is how we kind of look and know information about the stars using the system that she created. Interestingly enough, this is not called the Cannon stellar classification chart. What's it called? It's called the Harvard classification chart. She had done a lot more work. She classified 225,000 stars altogether. If you think back to Wilhelmina Fleming, who was pivotal in publishing the Henry Draper catalog of stars, that was 10,000. This is now 225,000. This woman did a lot of work visually on all these photographic plates. So she's the first woman in the University of Oxford to be bestowed honorary doctorate. The American Astronomical Society has an award named after her and presents it to a female astronomer in the early stages of their career. One of the people that was rewarded that was another woman, but we don't have time to talk with her because she's done a boatload of stuff. Cecilia Payne Gaposchkin followed her, but Cecilia came to the Harvard Observatory after Pickering died. So she's not part of the Pickering's HAREM group, and so I elected to stop with some of those pivotal women with her. So there was some things that I just wanted to follow up with, and then I'll be done. And I'm going to read this part because it's a quote from a book that I don't want to mess up. Bill Bryson wrote one of my favorite books of all time, A Short History of Nearly Everything. Who's read it? It's a fantastic book. It's chapter by chapter. In this book, he writes of the women at Harvard, stating that, quote, half the finest minds available were directed to work that would otherwise have attracted little reflective attention, and women ended up with the appreciation of the fine structure of the cosmos that often eluded their male counterparts. So for me, this is kind of a strange irony, this notion that these women just did very mundane things, but they actually were blessed with a very detailed understanding of the universe right as we were getting able to understand those stars above us and being able to classify them and understand that, you know, hey, we're not the only galaxy. They were pivotal in that role, and they had a very detailed insight into that. But what I further like is that Bill Bryson goes on to write that, quote, to put these insights into perspective, it is perhaps worth noting that at the time Leavitt and Cannon were inferring fundamental properties from the cosmos from dim smudges on distant stars on photographic plates, the Harvard astronomer William Pickering, Edward's brother, who could of course peer into a first-class telescope as often as he wanted, was developing his seminal theory that dark patches on the moon were caused by swarms of seasonally migrating insects. So the women, without the equipment, just with their eyes and some magnifying glasses and hunched over tables for days on end, they came up with a system that was very complicated just by paying attention and noticing things. And they were much closer than he was, at least on that little aspect of that. So if we go back to the beginning of tonight, you'll recall that I mentioned the celebration of International Women and Girls in Science Day. The 5 women that we've discussed, in my opinion, need a little bit more than a day to be recognized and remembered. But they exemplify women who did things when they were doubted. One of the things that you should know is that these women who spent all this time at the observatory were not allowed to use the telescopes except for a couple. I think Leavitt might have been and Annie Cannon might have been, but they almost didn't want them touching the telescopes because they were too fragile to operate these very large telescopes, which I just find rather amusing, but they spent that much time there. The Harvard Observatory was a place that women sought out for employment. Pickering supported their work. He let them put their name on it. He wanted them to write. He wanted them to present. He nominated them for awards that society was not ready to allow them to have. So this man had an astounding relationship with this woman. And I think that's kind of the way life is today and the way it's supposed to be. Women and men think differently. We have different skills, we have different whatever, but it's very symbiotic, and I think it shouldn't be any different than in science. So just to kind of go back to why look at women in science, I don't know why we look at women in science. They've been around for years. They've been making contributions for years. I think the issues is that the history is often written by those who write it. That's how we remember it. And so if you don't hear these stories, you don't realize the contributions that women have already made. And because of that, for some reason, it's so shocking when we hear it. So I would just kind of close with, to emphasize, I have reason to believe, based on the job that I do in the engineering department, after looking at data for the last several years, they asked us to track women who left engineering, because they wanted to make sure that they had a diverse population and they wanted to see how many women were leaving. And so I tracked everybody who came into the department and left over the period of 4 years. It was not the women leaving. It was not the minorities that were leaving. It was the males that were leaving. And so I think the notion of once women get there, they stay. I think for our clubs, we have to be more involved with exposing the women to it when they're in middle school so that they realize that it's an option And that's where I think Roger's efforts, and I know Dave's with his astronomy students, to get people interested at an earlier age is so important, because then we'll be so overrun with females that have been exposed to this at a young age that we won't need a day for them to be recognized. So that's all I have, and I think you are up next.